Hello everyone, welcome back SM online class. In this class we are going to discuss to solve this two question. Okay, first question is n cube minus 7n plus 3 is divisible by 3 for all n belongs to n, and 4 to the power n plus 15n minus 1 is divisible by 9 for all n belongs to n. Proved by principle of mathematical induction. Okay, so solution of question number 1. So the statement is denoted by first P of n, that is n cube minus 7n plus 3 is divisible by 3 is divisible by 3. Okay, now for n equal to 1, that is P of 1, such that this is 1 cube minus 7 into 1 plus 3. This is 1 minus 7. This is 4. This is 1 minus 7. This is minus 6 plus 3. This is minus 3. Okay, and it is divisible by 3. Is divisible by 3. Okay, now let it is true for n equal to m. Let assume it is true for n equal to m. So P of m such that m cube minus 7m plus 3 is divisible by 3 is divisible by 3. Okay, if it is divisible by 3, that is m cube minus 7m plus 3 को हमें लिखी पारे कौन 3 into k, where k belongs to natural number. Okay, now we have to prove it is true for n equal to m plus 1. We have proved a equation हमें पाई पारे कौन, this is m cube equal to 3k plus 7m minus 3. Okay, 3k plus 7m minus 3. We have proved it is true for n equal to m plus 1. Okay, it is true for n equal to m plus 1. That is ताहले हमें फर्स्ट कोन बाहर करबा दे. Now we have to prove this is m plus 1 whole cube minus 7 into m plus 1 plus 3 is divisible by 3. Okay, so now m plus 1 whole cube minus this is 7m minus 7 plus 3, and it is equal to a plus b whole cube. This is m cube plus 3m square plus 3m plus 1. a cube plus b cube plus 3a square b plus 3ab square, that is a plus b whole cube. This is minus 7m, and this is minus 7 plus 3, this is minus 4. And the value of m cube is what? 3k plus 7m minus 3. This is 3k plus 7m minus 3 plus 3m square plus 3m minus 7m. 3m minus 7m, this is minus 4m. Minus 4m. And this plus 1 minus 4, this is minus 3. And again it is equal to 3k, and 7m minus 4m, this is 3m. Okay, and this is 3m square. Okay, and this is minus 3 minus 3, this is minus 6. Clear? Now m cube plus 3m square plus 3m, the value of plus 1, and this is minus 7m minus 4. ठीक है. Now it is equal to 3 common नला पर कितने आसिबो k plus m square minus 2. Okay, which is divisible by 3. Okay, which is divisible by 3. So we have to prove that it is true for what? N equal to m plus 1. So conclusion रे कोन लिखा हबो? It is true for n equal to m plus 1, for which it is true for n equal to m. Hence the statement is true, that is n cube minus 7n plus 3 is divisible by 3 for all n belongs to n. Now question number 2. Let the statement is denoted by p of n such that 4 to the power n plus 15n minus 1 is divisible by 9. Okay, that is for n equal to 1, we got here 4 to the power 1 plus 15 into 1 minus 1, and this is equal to 4 plus 15 minus 1, and this is equal to what? This is 19 minus 1, this is 18, and it is divisible by 9. Is divisible by 9. Okay, so P1 is true. So P1 is true. Assume it is true for n equal to m, that is p of m such that 4 to the power m plus 15m minus 1 is divisible by 9. That is 4 to the power m plus 15m minus 1 equal to 9k, where k belongs to natural number. और हमें पाएगा कौन 4 to the power m equal to 9k minus 15m plus 1. Okay, 9k minus 15m plus 1. So now it is true for n equal to m plus 1. We have to prove we have to prove for n equal to m plus 1. Okay, and for this we have to prove 4 to the power m plus 1 plus 15 into m plus 1 minus 1 is divisible by 9. Okay, that is 4 to the power m plus 1 plus 15 into m plus 1 minus 1 is divisible by 9. So now 4 to the power m plus 1, this is 4 to the power m into 4, and this is 15m plus 15, this is 15m, and 15 minus 1, this is 14. Okay, now the value of 4 to the power m is what? 9k minus 15m plus 1 into 4 plus 15m plus 14 equal to 36k minus 60m plus 4 plus 15m plus 14, and it is equal to 36k, and this is minus 60 plus 15, this is 5, and this is 5 minus 1, this is 4 minus 45m, and this is 4 plus 14, this is 18, and take 9 as a common, so it is 4k minus this is 5m and this is 2. Okay, is divisible by 9, is divisible by 9. Okay, so we have to prove that it is true for n equal to m plus 1, which is divisible by 9. So we write here it is true for n equal to m plus 1, for which it is true for n equal to m. Hence, by the principle of mathematical induction, the statement is true for all n belongs to m. Okay, so in this class we have solved these two questions. In the next class we solve another problems. Okay, so till that, take care and thanks to all of you.